Yeah, I actually recording this particular tutorial because I think some of you all have tuition or whatever. So there's a request, so I decided to record this particular lesson. Okay, so first, whenever you do experiment, right, you must know the theory, the concept behind it first. Okay, then now, so let's say we do this particular experiment, okay, carbon dioxide product or respiration. So you can see this from this simple experiment, right, there's this snails, and we are interested to find out whether what will be the product of respiration. So obviously we know that the snail will respire, give out carbon dioxide, and will change this lime water to chalky, okay, will produce a white precipitate. Then you have this potassium hydroxide solution in this conical flask A. What is the purpose of this? Okay, and then there's another lime water here. So you may be wondering how come there are two conical flasks of lime water. Okay, so the first thing that I will change the variable, right? The factor that's being changed to test the hypothesis that carbon dioxide is a product of respiration, okay, will be actually the independent variable. It will be the carbon dioxide concentration. So we know that the inhaled air, right, it is 4 to 5%, and the exhaled air is 0.3%. Okay, so this is an independent variable, and the dependent variable, okay, which is something I measured, right? Because I want to measure whether is there any carbon dioxide being released by the snail. So I can see that I can check that there will be a white precipitate formed with the lime water. So this shows that there's this carbon dioxide present in the snails. I mean, the snails give out carbon dioxide. So this is what we meant by dependent variable. I checked what is the product they are measuring. So dependent variable will be always something that I measure. So remember that. And the rest will be kept the same because the number of snails must be kept the same. And the inhaled air, right, the air that we breathe in, right, the air that is sent to the snails must be 0% concentration of carbon dioxide. To be fair, you cannot supply the snail with already some carbon dioxide. Then it won't be fair anymore because we want to check whether is it all the carbon dioxide is actually from the snail. The snail breathe out carbon dioxide. Okay, so we want to make sure that the inhaled air that is being sent to the snail contains 0% concentration of carbon dioxide. So how do I make sure that the air, right, is sent to the snail contains 0% carbon dioxide? It's actually, can you see this potassium hydroxide? So when the air that enter the conical flask A will go into the potassium hydroxide solution, and this potassium hydroxide solution will actually remove all the carbon dioxide. So all the inhaled air that's being sent to the conical flask B, I will do a check. I'll make sure that the lime water, right, will not have any white precipitate. So this to show to prove that whatever inhaled air finally being sent to the snails, right, will be free of carbon dioxide. And any the exhaled air that's being finally sent to the lime water over here, right, at D, will then be, well, if there, let's say there's a white precipitate, this prove it to me that carbon dioxide, right, is a product of respiration. Okay, so far so good. Okay, let's move on. So you can see that the constant variables will be the inhaled air must be free of carbon dioxide. Okay, the number of snails and the equal volume of lime water. Okay, so this will prove it to me that everything is fair. Whatever that the product that we're measuring, right, finally is actually all from the snail. Okay, then so summary, right, independent variable will be the carbon dioxide concentration. Okay, so the inhale is 4 to 5%, exhale air is 0.3%. The dependent variable will be whether there's present or absent of carbon dioxide. We check by the white precipitate formed with lime water. And finally, the constant variable will all this. So in questions like, let's say in the exam, right, practical exam, we'll look at more examples of what are the types of questions that will come out. So in a real exam, in a practical exam, when you are faced with such question, right, you must always remember these three things. You must write in your answer, right? You must indicate clearly the independent variable, okay? The dependent variable, and what are the constant variables. So later on, right, you will come with a conclusion. You will tell me, okay, let's say there is a white precipitate. This shows that carbon dioxide is being released. If there's no white precipitate, it means the carbon dioxide is not released. So you must not forget the conclusion bit. So in total, right, we will have all these, the independent, the dependent and constant, and followed by conclusion, right? Then you are very sure that you are able to score full marks for that particular part of the question. Okay, so independent variable means the variable that actually change. Okay, the dependent variable will be the measured variable. The constant variables will be kept the same. So in order to help you to remember, right, IDC will be I don't care, so that you remember. Okay, so these are the three things, right, I must write it down when I answer such question. Okay, let's take a look at more examples of the questions that we can look at. Okay, so now, for example, heat is a product of respiration. Okay, so what do you all think is the independent variable? And then what are we measuring? And then what are the constant variables? So what do you all think? Anyone? I want you all to think for a while. I know you are very shy and you don't dare to actually share with me the answer. You can think about it. So let's say we have this experiment, okay, and heat is a product, okay. So we are measuring the temperature, we are measuring heat energy being released. So obviously the dependent variable, straight away I know that is actually the thermometer, okay. Okay, straight away I know that something that I'm measuring, right, must be the temperature increase in the thermometer, okay. Okay, so we have this some P seeds over here in antiseptic solution, okay. So that why is it antiseptic? Antiseptic is similar to like sterilize, okay, to make sure that it's free from bacteria. It's very clean in a sterile environment so that the pea seeds are able to undergo respiration. Okay, so what will be the control? What do you think will be the control? So the control is actually the void pea seeds. So you can see this is the living pea seeds, okay, that is original, okay, fresh. The void pea seed means I boil it. Okay, I do something to it, I boil it. Okay, I denature the enzyme in the pea seeds. So straight away I know that the independent something that I change, right, is actually one that is the original, the fresh pea seeds, and the other one is a boiled pea seeds as a control. Okay, right. So you can see that. You can see the something that I change is a boiled seeds because I know that the dead seeds are unable to respire, and then the dependent variable, right, will be actually the temperature that I actually measured from a thermometer. Okay, if let's say there's an increase in temperature, right, this shows that heat is a product of respiration. And then constant will be the rest. So what are the constant variables, people? Huh? Anyone? Are you all sleeping? Hey, are you all sleeping? I hope none of you are sleeping, no? You can check with me. Okay, so I hope that at this junction, you know what am I talking, no? Okay, let me show you another PowerPoint slide. Hey, Hubert, you're looking at me, no? So cute. Yeah. Hey, can you tell me, you know what's going on now at the moment? Huh? Hubert, you can talk to me, no? Are you able to unmute? Yeah. Hey, Hubert, are you able to talk to me? Hello? Can you hear me? Hubert is very shy. Okay, anyway, let me share screen again. Yes. Wait. Why? Oh, okay. All right. Okay, I'm seriously, I'm very, very, very bad at all this. Okay, now I know what's the reason. Sorry, sorry. Okay, how do I unmute or y'all? Okay, let me go. Start video. Okay, participants. Oh no, what should I do? Okay, more. Ask to unmute. Sorry, it's really, okay. Okay, is it better now?
Ah, can already.
Okay, thanks. Finally there's somebody to talk to me. I felt so lonely, you know.
Say that.
Yeah, hey, just be yourself, okay? Yeah, okay. So, hey, are you able to see this particular PowerPoint slide?
Yeah.
Yeah. There's this control thing, right? Okay. So, oops.
Damn bad, sir.
Die.
Damn bad.
Hey, thanks for the support, no? Now I know who are the,
I thought.
you know. Okay. Hey, so I'm actually at a heat is a product of respiration. Am I right? Are
Yes.
you looking at this PowerPoint?
Yeah.
Yeah. So I can see that the independent something I changed is actually the PC must be something void. The other one is fresh. Okay. And the dependent will be the temperature change. You can see that there's any temperature changes resisted in the thermometer, right? This shows that heat is a product of respiration. And the rest will be all the constant variables. Okay, we must consider the cotton wool, the vacuum flask must be the same size, the number of PCs, okay, the antiseptic solution that I use for the control as well for the original experiment. So these are the consideration I need to consider for the constant variables. Okay. Yeah. Okay. So control, right, is designed to minimize effects of variables other than the independent variable, because you can see the what is this? Sorry, I go back to this. Yeah. So the antiseptic solution, right, I must use the same concentration for both the PCs and the void PCs. What is a void PCs? Yeah, the antiseptic solution that I use for the void PCs and the fresh PCs, right, must be of the same concentration, because if let's say I use different concentration, okay, the void PCs might have bacteria and the bacteria might respire and then will actually give me a result. Then this will actually give me an unfair experiment. Okay, so you must consider when you answer such question. Okay, right. So let's take a look at another experiment like the yeast glucose and the yeast suspension. So the independent variable will be the yeast solution. Okay, right. So there will be different concentration that I can consider. Okay, the dependent variable, of course, that I'm measuring is a carbon dioxide. Okay, that's being released. So you're able to see what precipitate means. Carbon dioxide is being released. Okay, did somebody message me? Oh no. Hey, you all can talk to me already, right? Hello? Oh no, again. The same old thing. Wait. Sorry. Oh my goodness. Hey, can you hear me already?
So I don't think the rest also I don't think the rest got permission to unmute.
Why?
Because you muted them.
No, I never.
There's this thing that you clicked on that's then.
Okay, is it better now?
No. Now you must say.
Yeah,
No.
Now can mute.
Sharon, can
Yeah.
Okay, yes, great.
Shut up.
At least you got mute.
Hey, I heard a cat. Is that a cat? Okay. Hey, sorry. Let's go back.
That's like cat.
Okay, where am I now?
I had to lose that.
Okay, sorry. Okay. Yeah, so where am I now? So wait. Hey, Sunny, can you hear me?
Hey, call me.
Sunny, yeah, great. Okay, you can hear me, thanks. Hey, so remember controls, right? I think you're aware is something the other variables I need to keep constant. Okay, so that this control, right, will not affect my results. Okay, so you must remember control very important. You know why I must really call for this particular meeting, because I mark your practical exam. I really had a shock of my life because a lot of you cannot write cannot do the particular question correctly. And I got another real surprise is the question of magnification. I don't know why many of you cannot do that particular drawing. You can draw, but when it comes to calculation, right, all haywire. Later I'll talk about that. Okay, so again, the IDC, okay, the independent, dependent, and control. So always remember. Okay. Oh, I need to. Okay. Share screen. Wait. Okay. Hey, how come now? Right. So let me go back. Okay. Okay, we are almost there. I'm not sure what happened again.
Or crash.
Okay. Hey. Right. Can you see the screen?
Yes, of course.
Yeah. So again, so hey. Okay. All right, where am I now? Okay, so remember to use this IDC template, okay, whenever you're doing experiment. Okay, let's say there will be a question on that. Okay, like in this case, like we know that he is a product of respiration. So dependent will be something that I'm measuring. The control will be the rest. Okay, so more or less I'm done with this particular lesson on IDC. Okay. So there are many different experiments, okay? So like respiration, we can even talk about water as a product of respiration. Okay, okay. Let me okay, stop share. I'm going to use another thing. Hey, okay, stop it. Okay, let me okay. Where are they? Share screen. Okay, let me go back to this. Okay, I'm going to refer you to this particular practical book. Okay, the first few pages on the experiment. Okay, you should have this practical book. Okay, they actually have more information about dependent, independent variable. Okay, but in particularly, I want you to look at this magnification. We really have got a shock of my life. Okay, so the first few pages of the practical book, right, you all can refer. Okay, they actually talk about, using the thermometer. Okay, this one I think all of you able to know, and like reading at the eye level. Okay, for thermometer, right, let's say there's a reading of 43 degrees Celsius, right, you must write down when you record the reading on your practical, right, you must have one decimal place, 43.0. Okay, stopwatch as well. Okay, like, can you see this example, the volume? Measuring eye level, 44.0. The bottom of the manacles. Okay, hold on. How come there's this thing? Right. Okay, then using the syringe. I believe you all know how to use the syringe already. Okay, it's actually looking at the, there's this ring level over here. So you actually measure at this junction, not at the tip. Okay, it's at this ring level, the bottom of the ring level, the marking. Okay, right, then okay, then there's another part. Yeah. See, like, for example, right, some parts of the leaf are being stained blue, black. You have to be very specific when you actually record the observation. If let's say there's only some parts, right, You must say some parts of the leaf turn, you know, you see, good observation, the parts of the leaf that were originally green were stained blue, black, while the parts that were originally white were stained brown of the outing desk. You see how they actually, write the observation. Okay, the blue solution turned from green to orange. So you have to be very, very clear. Turning from green to orange red. And then you cannot say no change. You must say iodine solution remain brown. So very common, very, very common mistakes. So always, write down properly. Okay, be very clear in your recording of results. Okay, then this is the one I'm gonna kill everybody. I don't know why. Magnification, you did very badly in that particular question in the prelim practical. Horrible, really, really horrible. I'm not sure what happened exactly. Okay, you must draw. Okay, use a pencil, draw a clean, clear, sharp outline. Okay, and use straight labeling lines. Okay, you must label properly. What?
Kevin got a question.
Yeah, yes.
Which is heavier, a kilogram of steel or a kilogram of feathers?
No, I'm not going to answer all this. Okay, so magnification, right, is size of a drawing over actual specimen. Many of you all draw the drawing so small, cannot, must be bigger. It must be 1 decimal place. So these are the guidelines. When you draw, right, must draw sharp, clear lines, showing all the details, proportion, okay, and the size, right. Make use of all the space available. Draw big and clear, and labels and magnification. So you can see, for example, somebody draw this particular flower. Okay, you can see this is a poorly drawn diagram because it's shade is like paint outline. Then you can see can you see here over here what is this? The labeling lines are cross line. Cannot, must be very clear, neat. Okay, and there shouldn't be broken outline as well. Must be straight line. So this is a very bad example, most commonly drawn by most of you. Okay, you should draw this nicely. You can see straight labeling lines, and then you must tell me the length. So you can see using a ruler, the length is 6.9 cm. Okay, they actually drawing a nectar guide, the standard petal, the wind petal, the sepal. Okay, and then so the actual size of the drawing, right, the flower is only 5.8. So you can see size of drawing is 6.9 divided by 5.8. So as a result, right, the magnification 1.2 times. There must be a time over here. There must be 1 decimal place. Many of you started to say your magnification is less than 1. You cannot draw small. Magnification must draw big. What's going on? Must draw big. So that's why I'm going to address this. Make sure you know, don't make this mistake in a real exam. Because in a real practical exam, right, there'll be a component that you will actually, right, draw. Yeah. And drawing will be about 3 marks. You can easily draw the 3 marks. Just draw what you are given. A cucumber, a chili, a tomato. Just draw.
Hey, Cher, I got a question.
Yes.
What happens if our magnification is exactly on the dot one times? Do we
Okay,
still,
1,
do we
1.0,
still need
okay.
to put it to 1 decimal place?
1.0.
Still must put 1 decimal place.
Yeah, 1.0. Even though 1.0 is okay, but cannot less than that. If you draw smaller, then it won't be valid. It will be wrong. Yeah, must be slightly bigger or at least the same. At least the same is not so bad. Yeah, so I got a shot, very speaking, that part many of you already didn't do well, no, serious.
How many passes?
I can't remember, I think half. 50% pass, 50% fail. Okay, then you can see, so dependent, independent, okay, plotting graph. Thankfully, you're no need to plot graph, only in paper 4, the coming exam. The coming paper 4, okay, there'll be graph, okay. So make sure that you know that X as this, Y as this, okay, plot properly. All right. Usually, in bio, right, when they actually give you this graph plotting, right, they will give you simple one. I mean, line to line, you can actually plot. They won't give you so difficult like a basket line. Hardly. Usually, the results, right, or the points that they ask you to plot, right, will be very nice, similar to mathematics, where you can draw a curve or draw a straight line. Okay. Okay, so this one I will not talk about the basic line. Okay, right. There's something that I need to address will be this one. Skipping. What's the science experiment? Okay. This one. Okay. Milligram, right? Let's say you measure something, it's like 2 grams, so you must record to 2.0 gram. Okay. Thermometer also is 0.5. So there's no such thing as 4.1 degrees Celsius. No, it's either 4.5, 5.5. Yeah. Okay. Then ruler as well. For cm is record to 1 decimal place. Vernier caliper you can ignore because vernier caliper is for physics. We won't be using vernier caliper. So if we are using, usually we're using ruler, it's 0.1 cm, 1 decimal place. Then for second as well, will be also 1 decimal place, like 4.5 second, 4.6 second. Then for measuring cylinder, usually right will be 0.5. That means like 1.5 cm cube. Okay, so really depends on the measurement. Okay, like 21 cm cube, 22 cm cube, 23 cm cube. So there must be 1 decimal place. So 23.0 cm cube, 24.0 cm cube is 1 decimal place. So same goes for the syringe, 24.0, 1 decimal place. So in bio, usually will be always 1 decimal place. Even magnification, 1 decimal place to help us to remember. So you can see in summary, right? Thermometer must be 1 decimal place. Let's say 44.0. 44.0. Gram also 44.0 gram. Okay. Cm 44. Let's say 5.0 cm. Okay, must be 1 decimal place. So to play safe, right? Usually bio, right, is always 1 decimal place. That's all. Okay. So I'm going to okay. So magnification. Because you know why the very first O-level practical exam is actually on the 1st October, if I'm not wrong. So you must always remember. Okay, let me look at one more example about okay, for enzyme. Okay.
How long this is? It's
Yeah, ending soon. I just want to show you one example on okay.
It's very interesting.
Ayo, how come he actually enter then go away? Okay, let me take a look at the potato script. Yeah, ending soon. Last one, the potato script. Okay. For example, this particular experiment. Okay. Can you tell me what is the independent variable here?
Potato
Something
script
that changed. No, potato script is all the same, but what is the independent variable here? What is something that I
or the
changed?
sucrose solution.
Very good, excellent. The concentration of sucrose solution you can see, right, is actually changing. Yes, that's an independent variable. Then what is the dependent variable? What are we measuring? Cheryl, you know what are we measuring?
The length of potato. The length
Thanks.
of the potato.
Yes, the change, right? The
Hey, must
final
wait for
length.
maths.
Say
Must
how,
wait in school by 8.
you say
He
how
got
was the
excited. Okay, never mind, it's okay. So, okay, I'm glad that you all know the dependent variable in this case, right? What we are measuring is actually the final length. Okay, good. Then what will be the constant variables? What must be kept constant for this particular experiment?
the original length of the potato.
Yeah, exactly. Okay, and the volume, right? The volume of the sucrose solution must be the same as well, right? Okay, so the original length of potato strip must be the same, and also the type of potato strip that I'm using. I cannot be like, okay, for this 0% sucrose solution, I'm using potato from Malaysia. Then 0.5 using a potato from another country. I must make sure that the potato is all from the same potato plant. It to be the fair experiment. Okay, so the different sucrose solution, the different concentration will be my independent variable. Okay. Okay, so the dependent variable will be actually the final length of the potato squid. Okay, And then sometimes they may ask you, I mean, how do I make the experiment more reliable? You can talk about covering the petri dish to prevent evaporation, because if any of the solution evaporated, there might be a change in the sucrose concentration. And then like the potato script must be obtained from the same potato tuber, okay, because this to ensure a fair experiment. Okay. Okay, what else am I looking at? Maybe, okay, anyone has any question at this time? Otherwise, I will really have to end the meeting already. Yeah. Anyone? Yeah, how? Anyone has any question? Otherwise, seriously, I'm going to end the meeting. I will actually print this particular PowerPoint slide to all of you. Yeah. How? Anyone okay? Otherwise, I will end the meeting already.
Yeah.
Okay. I will send this PowerPoint slide for printing for you all. Okay, so that you are aware lah. Then when school open, right, after the O level, I mean after the prelims, right, we'll go through all important things. Can I check all the test paper, other school papers have well complete? You all must do, no, seriously, you all must start to do already, because paper 4 Monday is your first exam.
Yeah.
Bio, yeah.
Can.
Go and do, seriously, go and do and check the answer, serious. I know Cheryl has been doing very good, keep it up. Okay, so please learn from her. Serious, and our past year O-level papers, really go and do, at least you all do 2019, 2018, 2017, at least 3 papers. Okay? Yeah, I'm going to end the meeting. I'm serious.
Yeah, European so.
Yes, I'm going to end the meeting already. Okay, thank you so much for your attention. I will send all the necessary for you all. Okay, okay, bye-bye.